right. So we've been talking about chemical compounds and chemical formulas now for a good little bit. All right. And so one of the things that we need to understand now, though, is this. We've said that let's go back. What was the purpose for the formation of a compound? What was the purpose? Why do compounds get made?
Because they need
Why?
to make them happy.
To make them happy. That was the whole point of a compound, is the element on their own are not happy. Okay? Because remember, when we do the valence electrons, right? The only ones that are happy are who?
Noble gases.
The noble gases, right? So every other element that's not a noble gas is not happy. So therefore, they have to find connections with other elements in order to try to find their happy number. Okay? Well, what we need to also understand, though, is this, is that sometimes when those elements form these relationships with other elements, they lose a little bit of their own identity, and they create a new identity in that new relationship. Okay, now that should also sound familiar to many of us as well. For those of you, sometimes when you're by yourself or with your friends, you act one way, but then when you're with your significant other, you act a different way. All right, because again, sometimes the relationship creates change, and that's the topic for today. Today's topic here is this. We're talking about physical and what we call chemical changes. Okay, so that's our title for today. Physical and chemical changes. We're going to start off with the physical because the physical is a little bit easier for us to grasp and for us to understand. But the first thing we need to do before we can get into any of these little issues up here is we need to know this. We need to know what is a property. Now, I believe we have mentioned this once or twice, all right, in this class. But what is a property? And I mean this in the sense of a chemistry environment, not in a outside of the regular world environment. What is a property? Does anybody remember? Very good. All right, so a property is a characteristic. Okay, it's a characteristic. So another title for today's lesson could be physical and chemical properties. All right, which means characteristics that are of a physical nature and characteristics that are of a chemical nature. All right. What we need to know, though, is we need to know what's the difference between a physical property and what a chemical property is. Okay, so that's our goal. So we need to know what's the difference between physical and chemical, and then we need to know kind of like some examples of what would be what. Now, let's get into the physical property. All right, so physical property. A physical property now is simply this. It is a way to describe, and in the end, kind of the point of the description is we're trying to identify something about the particular element or the substance, okay? Because usually we're going to use the word substance because a substance can refer to an element. A substance can also refer to a compound. In other words, a substance can refer to an element by itself, or it could refer to a compound, which is two or more elements combined. So it's a way to describe or identify a substance. But here's the kicker now. Here's the part that you have to really make sure that you pay attention to. It's a way to describe something, all right, but without changing its composition. Okay? And now here we get thrown another big word, all right, which is composition. So what we need to know now is what does it mean by composition? Anybody know? What's composition?
What is made of?
There you go. So let's go ahead and get that written down over here. So composition is what it's made of. All right. So in other words, if we were going to kind of relay this in a way that might kind of relate more to you, physical property is a way to describe, identify a substance without changing its composition, which means it's a way to describe something or a way to label something without changing what it is. All right, so like, for example, well, here's some examples of some properties, okay? Some physical properties. I'll use this one right here. We're going to go with boiling point. Okay? Boiling point is an example of a physical property because not all things boil at the same temperature. Now, if you're boiling water, right? Water boils at what temperature? Does anybody know? 212 what? Fahrenheit. Okay, so water will boil at 212 degrees Fahrenheit. Okay, or it will boil at 100 degrees Celsius. Okay, so it's same number. Like, let me rephrase that. It's the same heat, but different unit of measurement. Okay, Celsius and Celsius and Fahrenheit are two different units of measurement for temperature. But the whole point here is this: when water boils, right? What is actually happening? Now I know we haven't covered this yet, but you probably heard this if you went, if you learned this in elementary or middle school, right? Unless you went to Welcome. But what's happening when water boils?
The molecules
Evaporate. Okay, ready? Fancy word. Pretend I'm slow. What does that mean?
It turns to gas.
Turns to gas from what?
From water.
From water. It is water. From a liquid. Okay, so here we go. So ready? So let's kind of, because this is important that we have to understand now. Some of the words that we use got to be accurate. Okay, boiling point is like for water is when water changes from a liquid into a gas. That's the boiling point. Got it? But when it's a liquid, what do we call it? Or let me rephrase it. When it's a liquid, what is it made of? Water. Very good. That's why we called it water or dihydrogen monoxide, whichever one you want to call it, right? When the water boils, it changes into a gas. What is it made of? Water. You get what I'm saying? Like, what is it when it was a liquid? It was water. What is it when it's a gas? It is water. Matter of fact, it's called water vapor. All right? So, did it actually change what it is to go from liquid to gas? No. So, therefore, it's a way to describe something without changing its composition. So, if I have a liquid and it's clear would be a description, right? And I say, hey, this might be water. Well, all I got to do now is boil it. If it boils, and if it starts boiling at 212 degrees Fahrenheit, then guess what? I can now identify that this is probably water. Because now I know, based on that characteristic, that property, all right, of a physical nature, right, it's going to change from a liquid to a gas. It's still going to be water, but it's going to change from a liquid to a gas, all right? So that's a physical property. Now, there are a whole bunch of physical properties. So, for example, if we're going to, like, let's say this right here. Let's say I have this bottle right here, okay? So in this bottle, right, we have water. So we already know what it is. It's water, okay? Now, what are some ways we could describe that water? Like, in other words, what is some information I can get about this water without changing it into something else that is no longer water? Okay, clear. All right, what are we describing when we do clear?
You can see through it.
The appearance. Okay, well, there's a lot of things that are appearance, right? But specifically, what is clear going to deal with?
The color.
A color. Okay, so we'll go with that, even though color is not clear is not a color. But we'll go with that. All right, because again, if it were red, would you suspect it to be water? No, you would probably suspect it to be something else, right? What is red?
Kool-Aid.
Okay.
Blood.
I was going to go blood, but all right, go ahead. But hey, ready, maybe I'm just more, I'm not a Crip, so I guess that's why. So now the whole scenario here is this. So what are some other things about water? Again, this is what we're talking about. What are some other things that what is some other information that I can get? All right, well, first of all, hold on. I'm going to write this over here to the side. All right, we're going to put over here water. I would put it in your notes, just put it on the margin or someplace, just so that way you kind of know what we're talking about here. Remember, everything here has got to be a physical property. All right?
You want to start it?
Yes.
Okay.
So we're going to put clear. So like clear deals with color. All right? What else we got? Liquid, right? So let's go right here. We're going to go clear. That deals with color. Okay. Liquid. That deals with state. The state of matter that it is made of. Because I can just tell you, right? That's a liquid. Do you want to know something about that now? Yes, I do. Did it change what it is to find it out? No, it did not. All right?
I would say wet, but I think that's wrong. That's why I said I think that's wrong. Jiggly.
Okay.
Jiggly.
What else? Remember, what is some information you can get about this thing? Okay? Remember, I ain't talking about just your eyes. What else could you do to get information about it?
You drink it.
You can feel it. Get twisted.
Okay, ready? In the chemistry class, you don't drink something if you don't know what it is. Actually, let me rephrase that.
I mean, but we know.
Go ahead and drink something if you don't know what it is. Okay? That way Darwin will have his way and we'll have one less person to worry about in this world. All right? What else we got? Charles Darwin, evolution, process of natural...
Can't you read the thing?
Well, was it? Well, first of all, I could, but now I got less water in there. So I mean, you know, what I mean, I could, but I could still get the same. I can still get the same information. It may not be the same numbers, I guess you would say, but I can still get the same information about it. Carlos?
You can see how it reacts with other stuff.
No, I can't, because then I'm changing what it is.
Oh.
Okay.
What if you stir stick?
Okay.
You stir it. What? I don't know. I'm not an answer. Just okay, bro.
It's okay. Ready? Let me help you. Okay? This begins to explain the 44. All right? How much is in here? In science, we don't like to use those terms because then, you know, when we're trying to figure out the cure for cancer, we say, you got to do a little bit of this. How the hell much is this? I don't know. You said a little bit, right? So, how much is in here? About 3 ounces? Okay, so you think about 3 ounces. So my question is this. What information did you just give me?
It's the mass.
Don't know? They say the mass, but that's not true because we don't measure mass in ounces.
How much?
There's a word for it. We've already learned it. Test 1. Now, don't go flipping because it's going to take you too long to flip to that section. So, volume. So guess what? We could get, you know, liters, right? We could get a liters because that would be volume. All right. What else could I get? Again, I want to know information about the liquid that's in this bottle.
Is it possible to get mass on it?
Is it? Sure it is.
Oh, you
Because we did this when you did the friggin' liquid layer lab. We got a mass of a liquid, right? So mass, okay?
Did I say that?
I don't know, did you?
I did say that.
Did you raise your hand?
Yeah. Oh.
I mean, 'cause I don't know to look over there unless you raise your hand. All right. So what else could I get? What else were some information that water in here can tell me? I mean, we already just said 1, right? Can't I boil it?
Mm-hmm.
Yes. So will that change it from a water to something else? No. Because it goes from a liquid to a gas, but it's still water. Remember we just went through that? All right. So boiling. So if I get the boiling point, right? Ma'am? Freezing point then could be another one. All right. Tell you what can I use grams and liters to figure out?
Is it the ML?
Density. That's correct, Derek. Giovanni, good job. All right. So you get the density. All right. You can get the density. What else could you get? Like I said, some things that either you can measure without changing what it is. All right. Like the very word you said when you said see what it reacts. Well, if it's reacting, that means now it's being interacting with another element, and now that changes the scenario. Okay. Say what? We can go with the weight? Okay, we can go with the weight. It's kind of like the mass, but it's really not if you learn that in physical science. All right, so we can get the weight. What else? Let's get one more. How many we got up there? 8? Okay, let's see if we can get one more. What else? What other information can you get? Taste? Okay, yes, you can.
I know I said drink it.
Okay.
You said that's wrong.
It is.
Then why you put taste?
Because tasting and drinking is the same thing. Ready? What does it taste like?
Texture.
What's it taste like?
A liquid.
Okay, do you figure out the taste by drinking?
Ooh. Wait a minute. Hold on.
No, you don't. Okay, because I could just you could put a little bit. That's gonna sound crazy. You can put a little bit in your mouth and then you can just spit it out. Okay, you didn't have to drink it to figure that out. The taste. Okay, texture. All right, so we're going texture. Okay. Yes, but texture is usually determined by touch, right? Because usually when you touch something, then your senses are going to come to some kind of determination. Like, hey, that feels smooth. Hey, that feels bumpy, right? You know what I mean? Like that's, so you're touching, but just because you touch, that leads to a result or an answer, information. Are we good? So that's a physical property. Another thing that we could do is this. Where's the piece of paper? I'll do this right. Let me get a pair of scissors. All right. So all right. Don't look for perfection, or else I'll regrade your quiz, your test from Friday. Okay? Like I'll be as picky as you're about to be. So right now, take a look at this. What's in my hand? Paper. Okay, ready? So tell me something about the paper there, Logan.
Logan.
It's thin.
Okay. Malaysia, tell me something else. It's white? Great. So he just gave me, I don't know what that would be.
What did he say?
He said thin. You know what I'm saying? It's like, kind of, I guess that's sort of like a shape thing, maybe-ish. I don't know. All right. You gave me color, right? Michaela, tell me something else.
Even I would do that one.
It's a rectangle. Okay? It's a rectangle. So now, you ready? We're getting now to the next thing here. The next thing here is this. All right? I'm going to write down the word physical. A physical change. Now, the issue here with physical is, again, we're going back to that same idea. If it's a physical change, it's a change that the substance does, but it does it without changing its composition. It does it without changing what it is. Okay? Like, if you can date somebody who acts the same way around their friends as they do around you, then you know they're being real. Okay? If they act one way around their friends and then another way around you, then don't be disappointed when later on in life you ain't together, because they ain't going to work. Because they're two-faced, and they're letting you know right in front of your face. Okay? Now, that's what we're dealing with here. So a physical change is something that can change without changing what it's made of. So for example, Ms. Barrow just said that this was what shape? A rectangle. Okay? So, and what is in my hand again?
Paper.
Thank you. So here we go. I take my scissors. All right? And I just did what to it? I cut it. And now, what do I have in my hand? Triangle. What is in my hand? Paper. So it was paper when it was a rectangle. It's paper as a triangle. So again, shape is a physical property. All right? And changing the shape is a physical change, because I changed its appearance, but I did not change what it is. Do we get that? So the key here component for physical is, does it change what it is? If it doesn't change what it is, that's physical. All right? Because the other category is now when something changes to something that it no longer is anymore. All right? Like, for example, if I'm going to do this, I don't know if I can now because I can't see if I find it. Should have had it ready. Oh, here we go. Hopefully this will work. All right, so now, okay, ready? What did I just do to it? Burned it. Now, ready? Burning could be a physical change if what just fell? Oh, you didn't call it paper? Oh, so that means it changed into something else. So burning now is not a physical property. Burning would be a chemical property. Because now what resulted after the burn is no longer what I had to start with. So there is a complete recomposition, okay, a restructuring of its molecules and whatever else put it together, all right, because whenever you burn something, it's a reaction, all right, because it involves oxygen. All right, now, so let me erase the board and let's get into the more important one, all right, which is the chemical property. So everybody kind of understand the big idea about physical? Mm-hmm. So, for this one here, I'm going to go ahead and put both up here. I'm going to go ahead and put chemical property and chemical change. Because now I can just do 2 for 1. Because as you noticed, the definition for physical change wasn't really that much of a big deal after we understood what a property was, the physical property. So in a chemical property or a chemical change, what happens here is this. The substance undergoes the formation of a new composition. In getting the information. All right. If I was going to make it even easier for us to understand, I would put it like this. When we do a chemical change or a chemical property, it results in a new element/compound. Something new comes about it. So what you had before is not what you have now. So that's what we're dealing with there. All right. So results in a new element or compound. So what we need to know now is this. We need to know, so what indicates that a new substance is made? All right. That question right there is basically saying is, well, how do I know if it's a chemical change? All right. You'd know because a new substance is made. Well, then how do I know when a new substance is made? Well, then these are going to be the 5 indicators. These are the 5 things that you would see. These are the 5 things that you would try to look for that indicates a new substance is being made. All right. Number 1, simple. Color change. Okay. If it changes color, strong indicator that a chemical change has occurred. That the substance you have now is different than the substance you had to start with. All right, so a color change. Number 2. All right, number 2 would be the production of a gas. All right, the production of a gas. Now here's the problem. This room is full of gas. The gas in this room is called air, right? Hard to see air. Hard to see gas. So how would you know when a gas is being produced? Smell? Could. But, ready? Here's something maybe you did not know. The propane gas that is in your house that maybe is in a fireplace, a stove, or whatever, it actually, in reality, has no odor to it. They add the odor at the company so that way they'll know when there is a gas leak. Okay? So normally the gas has no odor. So how else could you determine whether a gas has been produced?
Could you?
Like what? Breathe. Well, that's fine. Not me. Remember, sulfur dioxide might kill you. You might not want to, ready? That's how we might, yes, we could. If Bobby drops, we know that there was a gas produced, right? But there might be a safer way to determine whether a gas was made.
Could you feel it or not?
Could you feel it? Well, that would mean you touch it, right? Some gases, when they make exposure to the skin, you ever hear of like things called chemical warfare? You ever hear a word called chemical warfare? Right? Well, that's when they use gas so that when it makes contact with the body or with the skin, it destroys it, I guess you could say. All right, so Johnny.
Check the mass of the element.
You can check the mass of the element. Okay, ready? I'm going to throw this at you right now. There's a thing called the law of conservation of mass. Okay, we'll learn more about that probably tomorrow, more definitely probably on Friday if I haven't gotten it by Friday. But the law of conservation of mass says this. It says the mass of things to start must be the mass of things to end. So while I like your thinking, that probably won't help because according to the law of conservation of mass, the amount I have to start will probably be the amount I have to end. Okay? So what's another way? However, I'm not making fun of you. I'm not calling you dumb. I'm just saying, what are some other ways to think? Of how would you know if a gas has been made? First of all, you had some good ideas.
Like an alarm or something?
An alarm, that's a whole fancy thing. Ready? I can create one that's cheaper and quicker, and I don't have to invent anything.
Could you use something before and after to see how it changes?
It depends on what you mean by that. So I have to know.
What type of gas?
You're just throwing big fancy words, right? Now let me throw science words and see which one sticks on the wall. All right. Let me ask you this: has anybody ever had a slow leak on a tire? Has anybody ever seen somebody try to figure out where the leak was in a tire? How did they do that?
Or you can feel.
They what?
Spray some water and soap.
And how do they know where the leak was?
Some both.
Oh,
Well,
okay. Sometimes the leak is slow. When I say a slow leak, what that means is this: you put air on Monday and it's flat on Friday. So it'll last a long time. A leak like that is going to be really slow. So that means the air ain't coming out that quick, so it means you probably wouldn't feel it. But Giovanni is absolutely correct. The biggest indicator of a gas is you will see bubbles. Because you can't see the gas, but you can see the bubbles that the gas makes. All right? I mean, look, honestly, I'm pretty sure
bubbles.
that most guys in this room, either when they were younger, when they were in the pool, or when they were in the tub, produced bubbles. Because when they're in the tub, how do you know when they farted? Because you'll see the bubbles. All right? Now, you could be like my son when he was like 18 months, and he thought he made bubbles. And then
all juniors with the last name
some more stuff came out after.
A. Please proceed to the 400 wing at this time. Last name A through K juniors, please proceed to the 400 wing at this time.
Wait, no,
I'm glad we got this on video. All right, so it's me, man.
no, because we leave it alone.
All right, so here we go. Number 3. Number 3. Okay. Is a change in temperature. All right, a change in temperature. Now, change in temperature can mean this. It can mean that the temperature increases or a temperature decreases. All right, so a change in temperature. All right, talk about it outside. If it's that important, talk about it outside. We're good. All right, so a change in temperature. Get warmer, get cooler. That's what we're dealing with there. Change in temperature. We good? Mm-hmm. Number 4. Change in odor. Okay, notice this though. Ready? Let me rephrase that. I'm taking out the word detect. A change in odor. All right. So in other words, it had no smell to start, and now it has a smell. Well, that's a change. Or it smelled like roses before, but now it smells like poop after. That's a change. All right. Or flip that. It smelled like poop before, now it smells like roses. That's a change, right? So a change in odor. Strong indicator that you have a new material that has been made, a new composition, okay?
Is like fertilizer like when you use fertilizer to do plants and stuff and crops? Would that be like?
Well, no, because there's no change in odor. It smells like crap to start because it is crap, and it smells like crap afterwards because it's still crap.
Like, wouldn't the crap smell like deteriorate?
No,
It's like,
no, it wouldn't deteriorate. It diffuses. All right. So it's still a crap smell. It's just in lower concentration because of diffusion. Number 5, the one that you probably need to remember for the rest of the semester. The one if they're going to test you, this will be the one that they test you. It's called the formation of a precipitate. All right, precipitate. Now, I can understand when most people will get this confused because when they hear precipitation, they think of what?
Rain.
Rain. This is the exact opposite because rain is a what? A liquid, okay? But a precipitate now is this. Here's your definition. Give me some room. A precipitate is a solid made by mixing two liquids. Okay? If I take two liquids, like I could take two clear liquids, and then when I mix them together, I will create a white powdery substance, all right, in addition to another liquid, right? So usually the way that works is this. You'll create a powder, right, and then but it'll also be mixed in with another liquid. So like if you ever put flour in water, right, and then you mix it, what does it look like?
Yeah.
Flowery water.
Right, so what would it look like, though? Like, how would you describe the appearance?
Chunky, like.
Chunky. All right.
Chunky.
Huh? Smooth?
First it starts out chunky, but then it turns into.
I'm just talking about, no, I'm talking about you have a glass of water, you pour some flour in it, and then you just stir it up. What does it look like?
Yeah, like
Type of paste? Kind of, okay, well, ready? I even threw it on the board for you, so you might say it. It has that milky appearance. Because it ain't clear, right? It ain't like, it's not like when you put sugar in water. When you put sugar in water and you stir it up, the sugar dissolves. It disappears. So it still looks clear. Flour is not going to dissolve. It stays there. So that's why when you stir the flour around, it just gets milky or cloudy, right? Well, that's again, whenever you create something that's got a cloudy appearance, like it was clear, you put them together, and now they got a cloudy appearance, you have basically formed a precipitate. Because all you got to do now is take a coffee filter, pour it through the coffee filter, you'll see the powder stay on top of the filter, and you'll see the other liquid kind of pass through, right? That's literally how they cut drugs, okay? Except they use different chemicals to do that with, all right? So that's what we're dealing with here. So you got color, changing color. If they produce a gas, how do you produce a gas? You're going to see bubbles. You change in temperature, change in odor, and then the formation of a solid by mixing two liquids. When you get that, those are your basic, strongest indicators that a chemical change has occurred because it's resulting in a new element or a new compound being made. All right, are we good with that? Everybody understand that? All right, so for right now,